Good afternoon, everyone. This is the lesson recording for Social Studies. For Social Studies 20-2_week 6. What I'm going to do today is basically go through the lesson step by step and just clarify the instructions and some of the concepts that we are going to be looking at this week. So let's get started. For days 1 and 2, which would have been yesterday, Monday, October the 4th, and today, Tuesday, October the 5th, I wanted just you to go through this introduction and do some self-correcting questions regarding the readings. So let's start with step 1. Last week we explored how people can reconcile their nationalist and non-nationalist loyalties. This week we will be looking at how a nation. Whoopsie, I think I might have made a mistake here. Just let me quickly check something. I might have missed part of when I was. Okay, I think, yeah, sorry, I think this was just added by mistake. I'll have to make that correction. So just continue reading. In order to draw you into this chapter and the issue it examines, please read page 109 and view the map on page 108 in your textbook, Understanding Nationalism. While viewing the image, please think about the following questions. And remember, when just reading this page 109 and looking at the map, you don't actually have to record your answers to these questions right here. You just have to think about them and how you would respond. So think about how might the peoples of the old Ottoman Empire have reacted to living in a new country. What might Britain, France, and the United States have gained by creating new nation states in the Middle East? What nationalist emotions might the people living in the new countries have felt? Okay, so just think about how you would respond to those questions while you're reading page 109 and 108. Then step 2, I want you to read chapter 5 in your textbook, Understanding Nationalism, and it's on pages 109 to 128. Step 3, in your notebook, I want you to write the title, National Interest in Foreign Policy, and then I want you to answer these self-correcting questions right here that are written right in your lesson. Now, there's more than this. You will see when you scroll through the lesson. I'm just putting a sample in here. And just follow my instructions. For example, number 1 says, please review page 110 in your textbook and respond to the following question. List 5 personal interests that are the most important to you. Circle those that you think will still be important to you in 5 years. Underline those that you think will still be important to you in 10 years. What does this list show you about the nature of interest? Okay? And I think you'll find that they change as you get older. So anyway, I want you to answer these in your notebook, and then there's an answer key in your key parent's mailbox, and when you're finished all of them, I want you to complete step 4. And what you need to do for this step is answer yes or no to this statement. I have read pages 109 to 128 in the textbook Understanding Nationalism. I have completed the journal exercise and questions in my Social 20-2 notebook and checked my answers with the answer key provided in my key parent's mailbox. So you'll circle yes. Then using this rubrics, I want you to mark your self-correcting questions out of 5. The whole assignment, the whole self-correcting assignment is marked out of 5. And remember, you don't have to have your answers worded exactly like the key answers, but you have to be on the right track when comparing responses. So if you're on the right track to pretty much all of them, give yourself 5 out of 5. If you had the right idea for pretty much all of them, maybe 1 or 2 you missed the point, give yourself 4 out of 5. Okay, and then so on down the rubrics. Okay, then moving on in the lesson. For day 3, which will be tomorrow, there's an exercise I want you to do, and it's called Exercising Media Literacy with the Internet. And what this is going to teach you how to find out if a website is a good website to use for a research project. So follow the steps again. Step 1, please review pages 114 and 115 to 115 in your textbook, Understanding Nationalism. On these pages, you will read about Canada's national interest in the Arctic's Northwest Passage and how the Canadian government has laid claim to it. In step 2, I want you to pretend you are doing a research project on the Northwest Passage. You have found a website, but you are not sure if it is a reliable and authentic source of information. The website is as follows, right here. I give it to you in the lesson. Please explore this website and as many links at it as possible. Once you have thoroughly reviewed the site, please complete the following website assessment chart right here and make conclusions to whether or not it is a reliable and authentic source of information for your pretend research project. Remember, the point of this exercise is just to learn how to examine websites and whether or not they're good sources of information. You don't actually have to do a research project on the Northwest Passage. You just have to examine this website. Okay, so on this chart, I want you to go through the criteria and rank it 1 to 5. 5 is excellent and 1 is poor. All right, let me explain. So for the criteria, after viewing this website and all its links, I want you to look at, first of all, its credibility. Determine the source of the internet material. Okay, and ask yourself these questions. Was the information produced by someone from the website, a newspaper or television company, an editable encyclopedia, a book publisher, or a blog from an author or participant? I want you to ask yourself, what's behind this website? Who created it? And I want you to, in this box here, as I mentioned right here, I want you to write as much information regarding the company or person that created the website and rate its reliability. So I want you to tell me, who's behind the website? What are the people's names? Do they have any journalistic credentials like PhDs in journalism or research? And I want you to write as many point form notes about who produced the website. And then, based on this information, give the credibility a rating of 1 to 5. Now, if you find here that the people that write at the website have PhDs or university degrees in journalism and research and have explored the North and have all sorts of reliable experience, then I would say give it a 5, because that would be excellent credibility. But if you find that the person or people behind the website are just anybody with no real educational background, I might give it a 1. And you do this for all the criteria listed in the lesson in this chart. The next one is accuracy. And again, you write about the website's accuracy by asking yourself these questions right here, explaining what accuracy refers to. And then rate the accuracy of the website. Now there's some more criteria, and it's all listed in the chart, and you follow the same process right down the chart. Okay, and then at the end of it, at the end of it, you're going to need, I got to upload an image that I missed. Okay, after ranking all the criteria, you will get a very good idea of whether or not the website is worth using or not, and you need to write a summarizing paragraph explaining if you would use it for a pretend research project or not, and explain your position. So you've done all the analyzing here in the chart, right here, okay, in the chart. And so based on these scores, you're either going to have a high score for it or a low score. And that will tell you whether or not you would use it. And then you can just go through your evidence of the criteria in these boxes, okay, right here, whoops, and explain why or why you wouldn't use it. Why you would use it or why you wouldn't use it in a paragraph response. Alright, so, and that's it for that exercise. Now for days 4 and 5, you're going to do an exercise on the Treaty of Versailles. As you have learned so far, a nation, state, or country have national interests that they pursue. These are interests that the governments of a nation-state pursue on behalf of its citizens, usually with the majority supporting the endeavor. These pursuits sometimes conflict with national interests of other nation-states or countries, thus creating conflicts. These conflicts can be resolved through foreign policies that will either call for military action, diplomacy, economic tariffs, and or negotiations of treaties. One such piece of foreign policy that was shaped by pursuit of national interest is the Treaty of Versailles. Now, you're going to read about the Treaty of Versailles in step 1 on pages 116 to 120. And it's the treaty that ended World War I. And there was a number of European and countries that negotiated, and North American countries such as the U.S. and Canada, that negotiated the Treaty of Versailles with Germany. Now, you'll also get more information about it at this website. So you need to spend some time reading about the Treaty of Versailles and its purpose, and which countries were involved in the negotiations. Again, at these page numbers in your textbook and at this website. Then you're going to read a number of statements down here regarding the treaty. What you need to do is read the statement. For example, the Treaty of Versailles of 1919 was a fair settlement. Now, all you need to do is either agree or disagree with that statement based on what you learned at this website and at these pages in your textbook. Okay? Now, if you agree with it, you'll write an A in this box right here, underneath agree or disagree. If you disagree with the statement, if you think that the Treaty of Versailles was an unfair treaty, then you would write a D in this box for disagree. Now the point though you have to, or the most important thing you have to do is if you disagree with this statement, then you have to give me 2 pieces of evidence that tell me that support your opinion that you disagree with this statement right here. Alright? So you have to get 2 pieces of information that support your opinion that it was not a fair settlement because you would have disagreed with it. The next one. There were clearly losers and winners at the end when the Treaty of Versailles was signed. Now you might agree with this, but you have to tell me why in point form, 2 reasons why you agree. Or you might disagree, okay? But still, you have to give me 2 reasons why you would disagree. And that's it for this week. Now there's more questions or more statements in this assignment. I've only put in a sample of them just to get you going with the assignment. So for this Friday, you need, for days 1 and 2, you need to send me step 4, and that's back here telling me that you did this is step 4, telling me that you did the self-correcting work. Okay. Whoops, I put it in twice. Step 4, telling me you read these pages, you did the journal work in your notebook, and hey John, sorry John, I'm just finishing up a recording, and then I'm sure Mr. Knutson will have you in the session, okay? Okay, you're welcome to listen to my recording. I'm just finishing up right now, so, and then stay in the room if you all. Actually, John, you're going to have to log out of the room, otherwise my recording will continue into Mr. K's session. So if you could log out and then log back in about 2 minutes, that would be great. Sorry about the interruption. So anyway, this was the work that you needed to send me for days 1 and 2. Your response to this question. Oh, sorry, John, I'll be out in like 2 minutes. Sorry, I'm just finishing off a recording. Thanks, John. John, I think you're gonna have to log out, because otherwise I've had where the recording continues for some reason. Like I'll get your math lesson. I've had that happen before. Thanks. Sorry about that, John. I'm 1 minute and I'll be done. Take care. Okay, one more time. Okay, so step 4 for days 1 and 2. That was the statement that you need to send me, that you did the self-correcting work, and your mark out of 5 once you compare it to the answer key. Then you need to send me your website evaluation and your paragraph telling me whether you would use that website on the Northwest Passage for a research project, or if you would not use it, and tell me why based on the chart evaluation. And then days 4 and 5, send me your assignment for the Treaty of Versailles. And that's due by this Friday, and I hope everyone has a wonderful Thanksgiving. Hard to believe it's Thanksgiving weekend already. Anyway, have a great week, and thanks for listening to this recording. I hope it has helped.
Recording started.
Okay, hi everyone. Now here we are for our review session for Test 1 for Math. And we're just going to kick it off with a cartoon here. And so because we're going to talk about division at this point, the guy here, he must be a cell. I'm not sure what kind of cell, but he says, Marty, I'm just about to divide, so I can't make it for lunch. Both of us will have to get back to you. So anyways, a little bit of a science joke there to kick us off. And so we'll get right into just talking about some divisibility rules. So I'm just wanting to find out if you guys can remember some of these divisibility rules. So guys, how do you know if a number is divisible by 10? What kind of clues do we use in the number to tell if it's divisible by 10? Okay, it has to end in a 0. Would you agree, John? Okay, good stuff. So 10, 20, 30, 40, 50, all divisible by 10. Too easy, right? Okay, next question. How do you know a number is divisible by 5? Okay, it must end in a 5 or a 0. 5 or a 10. So it's actually going to end in a 5 or a 0, right? Okay. That one's pretty easy as well. How about if a number is divisible by 2? How do we know that? If it's an even number, good. Okay, so these first one were pretty straightforward. Let's look at the next one. How do you know if a number is divisible by 3? Do you remember what the rule is for that? Okay, the sum of the digits must add up to be divisible by 3. That's right. Okay, so I just wrote that on the next screen here. Good. All right, so step 1, we add up the digits in the number. If the sum is divisible by 3, so is the number. So here's a big, long number, but all we need to do is add up those numbers. And since 9 is divisible by 3, therefore 12,123 is. Good stuff. Okay, so with that in mind, do you guys think 343 would be divisible by 3? That's right. And the reason is it adds up to 10, and 10 is not divisible by 3. So, good stuff. And how about the next one, 459? What do you think? Okay, that's right. It is, because 18, 4, 5, and 9 adds up to 18, and 18 is divisible by 3. Good. And how about, is 459 divisible by 9? What do you think about that? Okay, that's right. It is, and we'll go over the rule for that. So the rule is very similar to dividing by 3. If we add up the digits and the sum is divisible by 9, so is the number. So if we add up this number here, 43,785, the digits add up to 27. Since it's divisible by 9, so is 43,785. Okay, so the number 459 is divisible by 9 because the digits add up to 18, and 18 is divisible by 9. So it's divisible by both 9 and 3. Okay, how about this next one? I'm not even going to read the number here, but do you think that's divisible by 2, 4, 6, 8, or 10? Okay, which do you think it would be divisible by? Which one of those? Okay, now remember, it's got to be an even number to be divisible by 2. So since it's an odd number, it won't be divisible by 2, right? And if it's not divisible by 2, it can't be divisible by 4, 6, 8, or 10. Okay, does that make sense? Okay, but is the number 1 showing up as well for you guys? It should be 1, 2, 3, 4, 5, and then 4, 3, 2, 1. Is the last one showing up? Okay. All right. So I can see what you mean then. If it would have been divisible by 2, then if it would have ended in 2, then it would have been divisible by 2. But since it ends in 1, it's not divisible by 2, and we know that because it's not divisible by 2, it can't be by 4, 6, 8, or 10 as well. Okay? All right. So, and stop me at any point, guys, if you need to. Okay, now we're talking about something, instead of talking about dividing, we're talking about multiples. But we're talking about multiples and least common multiples. So I got a little cartoon here, and so it shows, you can read it yourself, 1 times 1 is 4, and he gets up to 4 by 4, and he says that equals, 4 by 4 equals how Mommy drives me to school. Hey Joelle, how's it going? Good stuff. So, yeah, if you want to check out the earlier part of this, I think that it's possible our recording is going to tie into Mr. Smart's. It's all going to be on one big recording. We tried to get out of the recording and get back in it, but for some reason when we got on it, it still had social studies stuff there. So, anyways, no problems. We'll just we'll figure out how to get to the right page. I'll show you guys how to get to the right page when after the recording is made. So anyways, you can just watch the earlier stuff that you missed, Joelle. And we're starting here on multiples and least common multiples. And so I just got a little joke here that's showing some multiplying. And when this guy gets to 4 by 4, he writes, "How Mommy drives me to school." So yeah, okay, so what is a multiple? A multiple is some number you get after multiplying two numbers together. Okay, so since 3 times 4 is 12, 12 is a multiple of 3 and 4. And since 3 times 4 times 2 is 24, 24 is also a multiple of 3 and 4. Okay, because both of them have 3 and 4 being multiplied to get those numbers. Okay, so both 12 and 24 are multiples of 3 and 4. All right, so with that in mind, can you guys think of what some multiples of 2 and 3 are? Okay, so 6 is one of them. Any others? Okay, 6, 12, and 18. Good. Right on. How about 3 and 5? Can you guys think of some multiples of 3 and 5? $15, $30, and $45. Good examples. You guys are on the ball. Right on. Okay, I think you guys are getting this stuff. So that's multiples for you. And now we're going to talk about the lowest common multiple. So as the name suggests, it's a small number, right? Lowest common multiple. The lowest common multiple is the smallest number that two other numbers can divide into. So what's the lowest common multiple of 10 and 12? Well, it's 60. And we're going to look at how we find that, right? Okay, so how do we get that 60 is the lowest common multiple? What we do is we list all the multiples, first of all, of 10. That's what we're doing here. Okay, so we list all of them. Then we list all the multiples of 12, and we look at which is the first multiple that they both share in common. In other words, which is the smallest. And it's 60. So that's why 60 is the lowest common multiple, or we call it LCM. Sometimes people call it the least common multiple. Same thing. So 60 is the lowest common multiple of 12 and 10. Okay? So that's the lowest common multiple. The lowest number, or the smallest number that two other numbers divide into. Okay, so let's see how we do this in a problem. And this problem is actually in your textbook. You might remember it. But we're going to see how a lowest common multiple can be used to solve a problem with hot dogs. Now, I don't know if you guys like hot dogs, but we were talking actually at the campo. John might remember this. He came to the campo this year, but we're talking about people who can eat incredible amounts of hot dogs. And I think there was a guy in Japan who could eat, I don't know how many, if it was 40 or if it was 80, but it was some ridiculous number of hot dogs. So anyways, the problem we have here is one where we've got some hot dog wieners, and they come 12 to a package, and the buns come 8 to a package. Okay? So we've got different numbers for the wieners and the buns. The question we have to solve is how many packages of wieners and buns should be bought to ensure that you have the same number of wieners as buns. So in order to find that, we need to list all the multiples of 12. That's with the wieners. Okay, so we list them all, and we get 12, 24, 36, 48, 60. Then we list all the multiples of buns. Okay, and we get 8, 16, 24. And we find out which is the one that's the least common multiple. And it turns out it's 24. That's the lowest common multiple. Okay? So the way that works, because that's the lowest common multiple, how that fits in with our problem here is we would need to buy 2 packs of wieners, so 12 times 2 is going to give us 24, and we're going to buy 8 packs of buns, so 8 times 3 is also going to give us 24. Okay, so can you see why it would be 24 here? Because if we buy 24 with either buns or wieners, that's going to give us the same number. Okay? Is that making sense, John? Because again, okay. All right, and maybe if you just read this one over again, sometimes it helps to read it over again. Remember, what we're looking for is how many packages of wieners and buns should be bought to ensure we have the same number of wieners as buns. And as long as we have 24 wieners and buns, we've got the same, right? So if we have 2 packages of wieners, that will give us, that's going to give us 24, and 8 packages of buns, then we're going to have the same number, right? Okay, so let's go to the next one. Okay, so find the lowest common multiple for 6 and 9. So what's the smallest number that both 6 and 9 divide into? Okay, 54. So if we find all the multiples of 6, we got 6, 12, 18, 24, 32, what about, I did something wrong, didn't I, guys? 30, right, of course. Sorry about that. 36, and 6 is 42, 48, 54. Whereas if we go by 9s, we have 9, 18, 27, 36, 45, 54. And we can see 54 is the smallest number. Okay? Again, we're looking for the smallest number that both 6 and 9 divide into. I'm sorry, I said it was 54, and it should be 18, shouldn't it? Okay? So again, does that make sense? Why that's the smallest number they both divide into? I know sometimes there's a tendency to want to multiply them together, and if we multiply them together, if we were, say, finding the greatest common or lowest common denominator for 2 fractions, that's one thing we could do. We could multiply 6 and 9. Okay? But again, we want the smallest number they both divide into, and that's why it's 18. Okay, so how about 8 and 12? Sometimes we can do it just in our mind. 24? Would you guys agree it's 24? Can you think of a smaller number? Yep, I agree. 24. Good stuff. Okay, and again, we could write out all the multiples of 8 and 12, and we'll find out it's 24. Okay, so now we're going to talk about something different than multiples. We're going to talk about factors. So we've got a different beast here. So you have to really remember the difference between these two. Just remember that factors are numbers that are multiplied together to produce another number. Okay? So 3 times 4 is 12. That means 3 and 4 are factors of 12. Now that's what a factor is. When we talk about a common factor, it's slightly different. Why is it common? Where does the word common come in? Well, if we're looking at, say, 34 or 24 and 36, we look at the factors that multiply to make up those 2 numbers, so 4 times 6 and 6 times 6. And when we're looking at the common factor, we see both of them have 1 6 in them. So 6 is a common factor for 24 and 36. It's a number that multiplies together to make 24 and also multiplies together to make 36. Okay, so just to show you then, if you're asking the question, what are the factors of 28? If you want to find out what the factors are, one of the ways of doing it is to start with 2 and see if 2 divides into the number 28. So if it does, you find 2 factors. You've got 2 factors. So 28 equals 14 times 2. So we have 2 factors. 14 and 2 are the factors of 28. But we want to find out if there's more factors. Okay, so does anything divide into either 14 or 2? Well, we don't really worry about anything dividing into 2 because 2 times 1 doesn't really get us anywhere. We're looking for prime factors, and I'll talk about that more later. But we can break down 14 because 14 divided by 2 equals 7. So we found another pair of factors. So 14 is 7 times 2. So overall, we've got 28 equals 7 times 2 times 2. I'm going to show you in a bit how to use factor trees, and I think it's a better way of doing this, or at least I like it better. But if you want, you can do it by just starting with 2 and finding if it divides into 28, and then find out if the numbers that are left, 14 and 2, if any numbers can be divided into those. And you keep going. And if you can't divide 2 into a number, you can divide 3, and so on. I think it's a little bit more hit and miss in some ways though. So I like factor trees better. Okay, so we're done once we've once we found the factors 7, 2, and 2. So let's go on to the next one. What are the factors of 29? So when we ask this, we say, okay, does 2 divide into 29? No. Does 3? Does 4? Does 5? Does 6? Does 7? You know, and we start getting the idea there's nothing that divides into 29 other than just 29 and 1. So we can actually write a pair of prime factors for it. Okay, how about the factors of 21? What would that be? Sorry, I just got to log into the school again. Just give me a sec here. Okay. Okay, so 7 and 3. And can we break down those numbers anymore? No, we can't. So those are going to be the only factors of 21. Okay. So we'll talk now about a factor tree. And again, I really like factor trees because they help us determine the prime factors. So when we talk about prime factors, remember those numbers we came up with before when we said that 2 times 2 times 7 equals 28? Those are all prime factors because they're all prime numbers. Remember what a prime number is? A prime number is a number that only the number and 1 can divide into. So for instance, 3 is a prime number because only 3 and 1 divide into 3, whereas 4 is not a prime number because 2 and 2 also divide into it. Okay, so when we're done factoring, we end up with a bunch of prime factors. So that's what we're after with our factor tree. So here's an example, guys. The number 30 can be written as 6 times 5, and 6 can then be written as 2 times 3. So here's the factor tree. We take 30, we break it up into 6 times 5. The good thing about a factor tree, it doesn't matter which 2 you choose in the beginning. You can choose 6 and 5, or you could choose 10 and 3. No matter which way you do it, you're going to end up with the same prime factors by the time you're done. So then we take our 6 and we divide it into 2 and 3. We can't divide our 5 into anything. So these numbers here are our prime factors. So we say 30 equals 2 times 3 times 5. Those are its prime factors, and we can't break them down anymore. Okay, so I just want to show you guys, just so you can get an idea of how many different ways you can find the prime factors of 30 using a factor tree. So you could have started by breaking it up into 6 times 5, and you could take your 6 and you could put the 2 first and then the 3, or the 3 and then the 2. Those ones are pretty similar to one another. But you could also make it 6 times 5 is 10 times 3. And then once you've got 10 times 3, now you're breaking it up into 2 times 5. But you can see that the prime factors you end up with are the same, whether you started with 6 times 5 or you started with 10 times 3. And again, you also could have chosen 15 times 2. But by the time you're done, you're still done with 3, 5, and 2. So that's why I really like factor trees, because you know, if you were trying to get factors the other way, where you say, okay, I've got this big number, 430, and I'm going to start with dividing 2 into it, and then I'm going to divide 3. It's kind of a bit of hit and miss whether you've got everything by the time you're done, whereas with a factor tree, you're going to, it's always going to work out in a better, a more methodical way. Okay? So you guys can see how 2, 3, and 5 are always going to be the factors. And I already mentioned this point earlier, but these are the prime factors. 2, 3, and 5 are all prime numbers, so we call this prime factorization. Okay? All right, so let's do a factor tree right here, and let's do one for the factors of 44. So which numbers do you guys want to pick as the first 2 numbers that will multiply to make 44? Okay, 1 and 44. Yeah, we can do that. Normally I skip the 1. Okay, because we're just looking for prime factors, right? So we'll go to the numbers that multiply to 44, which are going to be 11 and 4. And can we break them down any more? Which one of those numbers can we break down more? Okay, and that breaks down to 2 and 2, right? Okay, so you guys can see that our prime factors are going to be 11, because again, we're looking at the numbers that are just prime numbers, so we don't even look at the 4, right? It's not a prime number. So 11, 2, and 2 are going to be our prime numbers, right? Okay, and see, what I like to do, guys, is I like to kind of set up this factor tree ahead of time, and that way you make sure it's all done. What about the 1? 1 is not considered a prime number. And so because of that, we actually don't include it. Okay? So when I draw these factor trees, I normally wouldn't even start with 1 and 44. I'd normally start with just numbers other than 1 and the number itself. Okay? All right, so we'll go to the next one. The next one is the factors of 100. So which 2 do you guys want to choose? 1 is fun. Yeah, 1 is kind of a funky number, and sometimes when people ask, is 1 a prime number? They kind of wonder to themselves, is it a prime number or not? But it's not considered a prime number. It's kind of a unique one. Okay, so you guys, by popular demand, you want the numbers 50 and 2. And can we break down those numbers anymore? What do we break them down to now? Okay. All right, we're going to just start with 50 and 2 for now, okay, Joel? I know another way we could have done it is 10 and 10. All right. And so 25 and 25. Okay, now what we actually want is the 2 numbers that multiply together. Okay, so instead of 25 and 25, which is adding 2 numbers, which 2 numbers will we multiply to get 50? Okay, so 25 and 2, good. All right, and can we break it down any further? What numbers are we going to multiply with what we have left? Okay. Sorry, Sherry, I know sometimes one person's typing something and I've already typed something else. I know we could have made 5 times 10 as well. Okay, so you guys are telling me that 25 will also break down to 5 times 5. And are we done? Okay, yeah, awesome. All right, so can you guys list just the prime factors of 100? Which of the numbers that are up there on the board are the prime factors? Five, 5, 2, and 2. That's right. So any ones that we've written up on there that are a prime factor are what we would write. Okay, so if someone says, you know, write all the prime factors, we're going to write 5, 5, 2, and 2. Okay, good stuff. All right, now we're going to talk about greatest common factors. I'm sorry, I ran out of time. I wanted to take this Superman and I wanted to switch putting the S on, having an S on his shirt, and I wanted to put DCF on his shirt, but I just kind of ran out of time. Shoot, Superman, say it ain't so. Superman is a Canadian cartoon, you know. He's got to be good. Winnie the Pooh's kind of Canadian too, I guess, in ways. I forget where he was created. I forget what province it was, but anyways. Kryptonite guns up. The flag behind him is the U.S. That's true. He's a traitor, isn't he? Oh, no. Yikes. All right. Okay, so the greatest common factor is the largest number that divides into 2 numbers. So the greatest common factor of 12 and 18 is 6. All right? So again, remember, factors are numbers that are multiplied together. We just imagine them with the times in between, right? Okay, so 6 is multiplied together to produce 12 or 18. 6 times 3 is 18, 6 times 2 is 12. Okay, so that's what the greatest common factor is. And so we're going to use factor trees to find the greatest common factor for 36 and 24. All right, so for 36, we break it down. We can break it down to 9 and 4 in the beginning. Then we break the 4 into 2 and 2. We break the 9 into 3 and 3. So you can see that the prime factors, I should have said of 36, are 3, 3, 2, and 2. Now we're going to look at 24. Okay, So 24, we start with 8 and 3. 8 is broken into 4 and 2. 4 is broken into 2 and 2. So again, we take all these prime factors, put them together, we get 2, 2, 2, and 3. Now what we do, to find the greatest common factor between 24 and 36, we need to write the prime factors beside one another. I'm just going to underline that. Write them beside one another, the prime factors. That's going to help us find the greatest common factor. Okay, so we do that. We write the greatest common, or the prime factors beside one another right here. And when we do, the ones that are in bold are the ones that are in common. Those are the prime factors that are in common between 36 and 24. And you can see that they're 3, 2, and 2. So then we take that 3, 2, and 2, and we multiply those prime factors together, and we get 12. So 12 is the greatest common factor between 36 and 24. And if you just think about it, 12 is the largest number that divides into both 24 and 36. There's other numbers like 3 that will divide into both, but 12 is the largest number. So that's why 12 is the greatest common factor of 36 and 24. Okay, so what's the greatest common factor of 25 and 40? See if you guys can figure that out using a tree on a piece of paper. Okay, got the hand clapping going on there. So 25 is equal to 5 times 5, and 40 is equal to 3 times 3 times 5. So what they have in common, the greatest thing they have in common, is 5, right? So would you guys agree that the greatest common factor of 25 and 40 is 5? Okay, good stuff. So, John's clapping for himself here. All right, good stuff. So how about 32 and 48? What's the greatest common factor with those two? You might even know, just some of you guys are going to be able to do this sometimes in your head, or depending on the mood you're in, some days you might be able to do this in your head. What do you think the greatest common factor is between 32 and 48? The largest number that divides into both 32 and 48 evenly. Okay, 8. Can anyone think of a larger one than 8? I'll give you a hint. There is a larger one. No? Okay, well 32 is equal to 2 times 2 times 2, right? And 48 is equal to, let me think, 16 times 3, right? So 2 times 2 times 2 is 2 times 3. Okay? So, if you have those factors in common, you can see they both share 2 times 2 times 2 times 2, which is 16. Because 32 divided by 16 is 2, and 48 divided by 16 is 3. Okay? So does that make sense now why it's 16? I know, sometimes these ones, sometimes they come more easily than other times. Alright. Good stuff. So, let's go to the next stuff. Okay. Let's find, okay, I just forgot about the fact that I was actually going to show you guys using factor trees. If you guys want to practice this later on, I'll be sending out a PDF file, and if you want to practice it later on, you could do the 2 examples we just did. Sorry about that, I forgot. I was meaning to do it on the whiteboard here. That would have made it a bit more obvious. So you can just practice those later on and see if you get the ones that we got just now. Okay, so we got a question here. It's going to use greatest common factor. We got real. I don't know if Mr. Mart is smart. Mr. Mart is smart. But I am not Mr. Mart. But I just bear his name. And I am not as smart as Mr. Smart. But every teacher who comes on the whiteboard session is always Mr. Smart. So I know students wonder about that sometimes. They say, why is Mr. Smart teaching us math? I've had students ask me that in the whiteboard session, and it is Mr. Knutson here. It really is. I could put the video on here, but anyways, Mr. Smart signed us up for this, so forever we will be Mr. Smart, and that's okay. Okay, so let's read this question, guys. Riel wants to tile a floor that measures 240 centimeters by 300 centimeters. What is what is the side length of the largest square he can use? Okay, so what we've got here is we've got this floor. Okay, this is 240 by 300. Okay, so I'm just gonna I'll even leave off the units here. 240 by 300. We want to figure out how large are these tiles going to be. You know, are they going to be, 5 by 6? Are they going to be 14 by 12? What are they going to be? Well, what we need to do, we know that it's probably either lowest common multiple or greatest common factor. Okay? But if you think about this one, it turns out that it's greatest common factor that we need to use to solve this problem. Okay? So if we can find out what the greatest common factor of 240 is, and of 300, we'll be able to solve this problem. So let's start with 240. All right, so help me out, guys. What two numbers multiply to give us 240? Okay, 24 and 10, good. And can you help me break down the 24 some more? Okay, we got 2 and 12 for the 24. And how about the 10? The two numbers multiply to give 10, 2 and 5. Okay, can we break anything down further? Okay, how about anybody got an idea? Okay, 12 is which two numbers multiply to give us that? 6 and 2, and in this particular situation, I did not draw enough of these, oh, no I didn't. Okay, so we got to make one more for the 6, and what multiplies to give us 6? Going to be 3 and 2, right? Okay, so 2 and 3. Okay, now we're gonna underline all the prime factors here. So the prime factors are 2, 2, 5, 2, 2, and 3. Okay, so I'm just going to write down all those. Okay, so 2 times 2 times 3 times 2 times 5. That's a lot of prime factors, eh? Okay, so that's 240. Now let's try 300. Let's hope we don't get quite as many. Okay, what two numbers multiply to give us 300? $30 and 10. Break down the 30. What are we going to get? Okay, 3 and 10. Good. Let's break down the 10. What do we get? 5 and 2, and same thing with the other 10 as well, right? Get another 5 and 2. Okay, so let's look at the prime factors here. Prime factors here, we got a 3, first of all, got a 5, we got a 2, got another 5, and a 2. Let's write all those down. Okay, so we got 3 times 5 times 2 times 5 times 2. Okay, so can anybody tell me which numbers from these numbers here are going to be in common? And you can write a number more than once if it appears in common more than once. Okay, 5, 2, and 3. All right, and do we have any more? One is very common but lonely. You love that one, hey? Good joke. Okay, so Sherry told us that it's, what did you say again? You said that, sorry, I'm trying to get back to where she typed in something here. Okay, got to make a bigger box here. So 5, 2, and 3. I just want to ask you guys, can we add anything else to the list that they share in common other than 5, 2, and 3? And remember, if a number is repeated more than once, you can add it. So if it was like 5, 2, 3, and then another 5, that sort of thing. Anything else, guys? Okay, we've got a 2 in common. We've got another 2 in common, right? We've got a 3, and we've got a 5. Okay, so we can add another 2 as well. Would you agree? So the numbers that are in common are 2 times 2 times 3 times 5. Okay? So overall, what do we get? 2 times 2 is 4, times 3 is 12, times 5 is 60. So 60 is going to be the longest length of a side that any of these tiles can have. Because if we have 60, if you think about it, we're going to have 240 divided by 60 is going to be 6, and 300 divided by 60 is going to give us 5. So that's the largest that a tile can be. Okay? So does that make sense how we did that one, guys? Okay, right on. So that's kind of a practical use of greatest common factors, and it's, you know, it's kind of cool. Like, I mean, someday you may be tiling the floor, and you may remember to yourself, oh, how am I going to do this? You know, what am I going to do? Oh yeah, greatest common factors. So math is kind of like the gift that keeps on giving, right? All right. So I just wanted to point out to you guys, remember the difference between lowest common multiple and greatest common factor. Lowest common multiple is the smallest number that two numbers divide into. So 60 is the lowest common multiple of 10 and 12. And greatest common factor is the largest number that will divide into two numbers. So 12 is the greatest common factor of 24 and 36. Okay, so just wanted to highlight the difference between those two there. All right. Now, I got a cool picture here. It says, I divided by 0. I found it on the web, of course. It's trying to show, you know, that if someone tried to divide by 0, what might happen? Well, there might be an explosion. You know, I came up with some other, when I typed in divide by 0, I came up with some other pictures where they showed like a black hole or something like that. Shows if you try to divide by 0, something really wonky happens, right? And so let's just, when we think about dividing by 0, when we go back down to the definition of what does it mean to divide, you know, when you're teaching kids when they're really young, like I'm teaching, you know, my kids, what does it mean to divide? When you divide something, you're actually dividing into groups, right? Like if you have a bunch of cookies and you say you're going to divide these many cookies into this many groups, that's what division really has to do with, right? Entropy won't let it happen. That's right. Good old entropy, right? Okay, so guys, if you divided 9 cookies into 0 groups, right? How much would you have? If you divided 9 cookies into 0 groups. You can't do that, right? You can't divide 9 into 0 groups. All right, so that kind of right there tells us there's a problem. It's actually not 0, and I'll tell you why in just a sec, okay? So 9 divided by 0 would not be 0. I know when you, maybe that wasn't the best example, because in some ways if you think about dividing 9 cookies into 0 groups, it seems like maybe it could be 0. But it turns out you can't. And as soon as you try it on your calculator and you divide 9 by 0, it gives you error. And it's like a big error flashes up, right? Okay, so we know that the answer for question 22 is we can't, okay? And we're going to talk about why we can't. But question number 23 says, explain why anything divided by 0 gives you an error. actually, I could tell you guys a little bit about why this is. This is actually a really complicated thing when you get into it. And people who are really, really into math and university and stuff, they discuss this stuff, you know, what does 1 over 0 really equal, right? And some people say it equals infinity. And other people say it equals negative infinity. And other, you know, really it kind of equals both positive infinity and negative infinity at the same time. And I know that sounds really weird, but I'll tell you why it does kind of equal positive and negative infinity, and that's why it gives you an error. Okay? If I have 20 and I divide by a number like 4, that gives me 5, right? Okay? Now if I divide by a smaller number, 20 divided by 2, that gives me 10. Okay, so I can see that the smaller the number is that I'm dividing, the larger my answer is. Now if I divide 20 by a half, that's going to give me 40, right? So the closer the number is to 0, if it got down to a really, really small number like decimal, you know, 0.00000, 20 divided by some number that's really, really close to 0 is going to give me a really big number. And so the closer this number gets to 0, the closer my answer gets to infinity, right? But the problem is that it can't be just positive infinity because it does the same thing from the other direction. So the answer is really both positive and negative infinity at the same time. And I know that sounds absolutely bizarre, but that's kind of the answer. So that's why our calculator just gives us a 0. So does that make sense, guys? I know it's not going to make total sense. But the main thing to remember is just have the phrase in your mind. You know, if you want to talk about like a commandment, and I kind of hesitate to make commandments because I don't want to, you know, I don't want to, you know, make it sound like I'm copying, you know, God or the Bible. But if you can say you shall not divide by 0, just remember that it's dividing by 0 that's a problem, but it's not dividing 0 by another number. Because if you had 0 and you divided, if you had $0 and you divided that $0 by 5 buddies, how much would each one of your buddies get? Okay, in this situation, the answer is 0. You can take 0 and divide by another number, and that will give you 0. But you can't divide by 0. So just remember that phrase. But you have to go. Okay, no probs, Joelle. Thanks for coming, eh? And you can just watch it. We're going to actually be wrapping it up in the next few minutes anyways, okay? But again, thanks for coming, Joelle, and we'll talk to you later, eh? All right, take care. We'll have a good day. Bye for now. Okay. All right, so 0 divided by 9, guys. What would that equal? Sorry, are you saying question 25 looks like 0? The whole looks like a 0. Sorry, what hole looks like a 0? The black hole? Yeah, that's a way of remembering it, eh? Okay, so guys, 0 divided by 9, how much is that? That's 0, right? 0 divided by 235, too easy, right? 0. Okay, we'll go on to the next one. 235 divided by 0? Error. Beep. Error. Okay. ABC 1, 2, 3 divided by 0 is going to give us error, right? Okay, so the next two kind of sum up everything. 0 divided by anything is going to be 0, and anything divided by 0 is always going to be error, does not compute. Okay, so just remember that. I won't say thou shalt not divide by 0, just you shall not divide by 0. Okay, all right, so a bit of a review, guys, over what we've gone over here. we're going to decide whether the following are divisible by 10, 5, or 2. Okay, so what do you think for the first number, 4,601? Is it divisible by 10, 5, or 2? Okay, which one will it be divisible by? The 10, the 5, or the 2? Remember, it's 4,601. Can we divide it by 10, 5, or 2? Okay, you're right. It's an odd number, so we can't divide it by 2. Okay. All right. So how about the next one, 46,050? Do you think that's divisible by 10, 5, or 2? Yes, all 3, right? Sorry, I should have asked you guys. I should have waited. It's divisible by all 3. It's an even number, so it's divisible by 2. It ends in 0, so that means it's divisible by 10. And anything that ends in 0 or 5 is divisible by 5. Okay. How about the last one, 148,088? Is that divisible by 10, 5, or 2? You're right. Only by 2, right? Okay, good stuff. All right, next question. Determine the greatest 3-digit number that is divisible by 3, 5, and 9. Huh. Wow. That's kind of a funky one, eh? Divisible by 3, 5, and 9. Greatest 3-digit number. Okay, well the greatest 3-digit number of all would be 999, right? Just to get us started. Kind of in the ballpark. Can you guys think of kind of a starting point that we could think of to help us sort of start with this? Any ideas? Okay, 990. Yeah, that's a good one, right? I was thinking we could use a starting point of 900, but 990 is even better because, okay, 975. Well, what do you think? Do you think that 990 is divisible by 3, 5, and 9? Okay, now if it's divisible by 3, we know it's divisible by 5, right? Because it ends in 0 or 5. What rule do we use to decide if it's divisible by 3? That's a cool symbol. Okay, digits equal multiple of 3. So if we add up 3, 5, and 9, we get 3 and 5 is 8 and 9. Okay, sorry, we're not adding 3, 5, and 9. What am I saying? We're adding together 9, 9, and 0. Okay, so if we add 9, 9, and 0, does 3 divide into 18, which is 9 plus 9 plus 0? Okay, does 9 divide into 18, which is 9, 9, and 0? Okay, so far 9, 9, and 0 looks like that would be the greatest digit, 3-digit number. Unless there's another one. Can you guys think of a larger one that they'd all divide into, or do you think that's the largest? Okay, that is the largest. Good stuff. Right on. Okay, so next question. So the rocks in a pouch can be divided into 2, 3, or 5 equal groups. Explain how identifying common multiples can help you identify the possible number of rocks in the pouch. So 2, 3, or 5 equal groups. Okay, well, let's think about what common multiples are. When we take 2 and we think about all the multiples of 2, we get 2, 4, 6, 8, 10, 12, 14, etc. When we think about the common multiples of 3, we get 3, 6, 9, 12, 15. When we think about the common multiples of 5, we get 5, 10, 15, 20, 25. Okay? So, those multiples help us to see that the lowest common multiple is, maybe we don't have it yet. So we have to keep going to get 16, 20, and we have to keep going here to get 18, 21, 24, 27, 30. So eventually we would get up to 30. And that would be the lowest common multiple for 2, 3, and 5. Okay? So, can you see then how that helps you to figure out the possible number of rocks in a pouch? Okay. You know what? I'm going to leave this one for now, I think, because I don't have enough space to really do more explanation on it. I didn't really leave myself enough space. So I'm going to come back and maybe send you guys an email just to explain this one a bit more. Okay? But let's go on to the next one for now. Okay? So question 34. If 3 and 9 are factors of 1, 2, 3, 4, identify the missing digit. Okay, so any ideas how we do that next one? If 3 and 9 are factors of 1, 2, 3, 4, so there's one more digit that comes after that, identify the missing digit. Well, maybe I'll just go over these guys because we need to, we just have a few minutes to wrap this up. Okay? Yeah, you're right. We'll just wrap this up because question 35 is actually our last one, so we're almost done. This one's very similar to another one we already looked at. We know that when we're looking at numbers that are divisible by 3 and 9, that we can add up the digits and they need to be divisible by both 3 and 9. If we add up the digits we have so far, we have 1, 2, 3, and 4. So that equals 10. Okay? So 10 plus some other number must be divisible by both 3 and 9. Okay? Now, if we do the math then, we know that both 3 and 9, they don't divide into like 12, they don't divide into 15, but they will divide into 18. So far, oh, I'm sorry to hear that, John. Okay, we're going to wrap up here, all right? Now, would you guys agree that if we made this last digit 8, that all these digits would add up to 18? And then both 3 and 9 would divide into 18, so we can say that that both 3 and 9 are factors of that big number, 12,348. Okay, does that make sense, guys? Okay, good stuff. And I'm just going to go over this last question really quickly. So last question says, every third car. Okay, so if you just want to read that one later on and check it out. And if you have any questions about any of these, you know, if you look at the recording later on and you're not sure, just fire me an email, okay? Now this one says that every third car is a convertible, or sorry, is green, right? So I'm just going to write the multiples of 3. And it says that every fourth car, I'm going to say equals green, all right? Now it says that every fourth car is a convertible. So we're going to say 4, 8, 12, 16, 20 equals convertible. All right? So this question says, find the first position where you have a car that's a green convertible. So it has to be both green and a convertible. So like John says, that's going to be 12. So you're going to have to go to the 12th car before you can make sure you've got one that's both green and a convertible. Okay? Good stuff. So we're done, guys. And so I'll send out the recording, and please use this to study for the test that's on Thursday. And again, if you also practice all the questions later on, I'll send out a file that had all these 35 questions on it. If you practice those, you'll have a very good chance of doing well on the test. And again, I'll also send you out some more about the one question that we didn't quite cover here. Okay? So I'll let you guys go. Thanks for your great participation, and hope the test goes awesome for you guys, and hope you have a great rest of the day as well. Okay, bye for now, guys.